actually imported the data, and it's actually literally just from the LMS, and then I viewed the PSI text, and then I use this, I click on data, which is on the Microsoft Excel, and then after that I just went to click on this from web. I entered my URL here, I imported it, and then I got the data. Hold on, let me move this aside. And I got the data, which is here. So I got this given data, and then I went to do this. I went to perform the data analysis on the five regions here, and then I went to apply data analysis to it, and then I clicked on descriptive statistics, and I clicked OK, and then this thing came out. So this thing actually helped me conclude which region had the worst air quality, which region had the best air quality. So based on this, I used mean, mode, and sum to actually derive the answer. So for the best air quality, I have concluded that region East is the best. For if you were to look at mean, he has the lowest mean among all. Basically what mean tells us that is the average of all the data. So basically every other day the PSI level is 28, which is, since it's the least, it kind of just tells us that it's the best air quality. So we move on to mode. Let's just move on to sum first, and then as you can tell, the lower the PSI levels, the better the air quality is. So the lower the sum, the better the air quality is. So region East has the lowest sum, which again shows that it has the best air quality. Then back to mode. Mode is not a viable method or measure to just say to actually prove that region East is the best. But when it interlinks with mean, it kind of actually tells us that it's the best, since it has the least mode in terms of just number. So what they're trying to say is that at every other day, and when they have tabulated the results, mode this 20 psi level appears the most. So basically, just from this and when it interlinks mode and mean, you can actually just say that every other day the psi levels are between 20 to 28. So based on that's how I derived region East as the best. And quickly, just to run through the worst, is the same thing. I use mean, mode, and sum, and the worst is actually west. Here the worst is actually the west. And as you can see, the mean is 34, highest than the highest. So worst air quality. The mode is the most among the rest. So basically every other day is the PSI level is between 32 to 34, and then after that the sum is the most. So basically just by that I've concluded that region wise is the worst. And this now is the maximum. This is the graph, the maximum, the daily maximum of PSI west. I've plotted this graph, and this is what I got. So let's move on to question 2. Let me explain what question 2 actually asked for. Question 2 actually asked to do to the confidence interval table, and then after that they asked us to tabulate the readings which are more than 30. They asked us to compare July and August as one group and September and October as another group. And since they said all regions, I decided to combine all regions together and then derive the whole table of confidence interval, which means all the calculations in the confidence interval are based on the 5 regions. So since they asked for the readings which are more than 30, and since they are of the 2 groups, I did this, which is the daily max. So the daily max of south, north, of all the regions of just July and August, when tabulated, the sample size is actually 13. Then when we tabulate September and October, the sample size is actually 11, and this is also the daily max. So bring on to question 2. This is the confidence interval. I got the standard deviation by using this formula. I got the mean by using this formula. Got the sample size, which is actually the days of the 5 months from June to October, and then which is the days. And then the standard error is actually just the standard deviation divided by the square root of the sample size, and the 0.5 is 1.696, and then the sampling error is actually the standard error times the z alpha. Lower limit is actually just the lower limit is actually just mean plus the sampling error, and upper limit is just the mean deducting the sampling error. And then moving on to lower significance. Lower significance is 0.01 as the question stated, which means the confidence interval is 99%. And then the sample size is 62 because this is just July to August. And then we got this because how do I get P1? We are using the formula test statistics for two proportions, and then so we have to look for P1 and P2, and P1 is actually, P1 turns out to be this number, because we have to take the sample size and divide it. No, you have to actually take no, sorry, let me think for a while. You actually have to take the bad air days of July to 13, which is then tabulated from here, as you guys can recall. Sorry, you guys can hear. So this is the number of bad air days. This is the number of bad air days for September, October. So as for P1, you have to take 13 divided by 62. So you got this number. And then the critical value is 2.575 for 99% in the world. 99 also stands for 0.99 divided by 2 is 0.475. 0.475 when translating to the z table is 2.575. Now this is how I define null and the alternative. P1 equals to P2, but P1 does not equals to P2, and test statistics is then all being made through this. This is just basically the test statistics for two proportions under in just one line. So this is the P2, the sample size for September, October. I got P2. Then for this, as you can see, it's H6 minus K6, so it's this minus this. It's P1 minus P2, and it's bracket, which is divided by the square root of H6 times 1 minus H6, and so on and so forth, which is basically just a formula. So I got the test statistics, and that's all for now. But then before I end it off, I just want to say that the test statistics does not lie in the rejection region, for there isn't insufficient evidence to reject the null hypothesis. Based on the sample evidence, there is no evidence to suggest that there is any difference in the proportions of both groups. And that's all for now. Thank you.